I'm Rachel Stevens. I am a senior analyst with a company called RedMonk. And RedMonk, we do basically industry analysis, which is trying to help vendors and users understand the trajectory of the industry overall. And so I am very delighted to be here today to moderate a panel with Kelsey and Viktor. Before we dive in, the team asked me to do an overview of the topic. I promise I know who you are all here to actually listen to, so I will keep this super brief as long as I can share my screen. What we're here today to talk about is the fact that we kind of have this framing of past, present, future for declarative infrastructure. That's a tricky framing in that past, present, and future exists at the same time in a lot of senses, because what's past, present, and future really depends on the organization that you're working in, where you're at in your journey, and also that a lot of these tools have a lot of overlaps with one another. So in theory, we're talking past, present, future, but really what we're trying to talk about is just trajectory over time. And we've been doing automated methods of provisioning and managing infrastructure in some format for a couple of decades. And the environments that we've been managing over these couple of decades have changed tremendously in that period of time. We've moved from kind of having everything on-prem to lots of things in the cloud or some kind of state of in between. We've done the mutable to immutable infrastructure moves. We've moved from various levels of distribution and scale expectations. And as these environments have evolved and have become more complex, it means that the tools that we are using to provision and orchestrate them have also had to evolve. So we started out with configuration management tools, and you can think about like Puppet and Chef. I know we're talking about declarative. Ansible probably falls in this category. We can certainly debate that if anyone wants to. They have infrastructure as code tools like Terraform and Pulumi. They have control planes now like Crossplane. And then when we get into the future part of this talk of past, present, future framing, what I think might be interesting for us to explore is the potential use of natural language to provision our infrastructure. So we're thinking about all these things. Our overarching storyline is going to be that we're working through a world that is getting increasingly complex. And we as an industry have a history of trying to abstract away that complexity. Our goal is to rise above the minutia, to rise above the toil, and to make it easier for us to do our jobs, and to make it easier for our colleagues to do their jobs, to provide that self-service opportunity for people, to make it easier for operation and development teams to interact. And so we might get to the AI section. It might feel more real to some of you than to others. It might feel like a stretch, but with or without AI as part of this storyline, the story is that we're coming from a world in which we had to articulate exactly what you needed to happen in order for your infrastructure to exist and for your application to run. And our direction of travel is moving towards a world where we tell the computer, like, this is what I need, please figure out the details for me. Like, it's an incomplete framing, but I do think that what we're trying to figure out is how to make our lives easier, figure out how these tools interact with each other, figure out what our overlap is, and figure out how we can all enable one another to do our best work. So that's the overarching storyline. I'm sorry I had to do it without slides, but hopefully that gives you kind of a sense of where we're going. So first question, and Viktor, I promise I didn't set this up to be deliberately combative. One of the things that I loved when I was kind of going through your past work preparing for this is you have this really an informative, engaging video series called DevOps Toolkit that I really enjoyed. I recommend everyone check it out because I learned a lot. But one of the things that I think makes it engaging is that you are not afraid of big statements. And so you did an episode back in 2021 where you were comparing IAC tools. And in that, you declared CF Engine, Chef, Puppet, and Ansible as either dead or on life support. So I guess where I want to start this panel is if we're talking about Princess Bride versions, like is it Princess Bride, like mostly dead or all dead? I think is like one version of the framing. And I think the other framing is, like, I guess maybe depending on your answer and how Kelsey also interprets this, is there space for tools like Chef, Puppet, and Ansible in today's workflows?
So I wouldn't use the word dead. Actually, okay. I used the word dead many times before, but I don't think it's the right word because nothing really ever dies in this industry.
Fair enough.
I think I hear echo from you, Rachel. Anyways, nothing ever dies, right? We still have big companies running mainframes. We still have mission-critical applications written in Fortran and so on and so forth, right? So things do not die, but things do go on what I would call life support. Now, that person on life support might have a huge family, a lot of people paying the bills and visiting and making sure that something is alive. But for almost every technology comes the time when it is not advancing at rapid pace anymore. It's not young. It is not running the fields and picking flowers and things like that, right? And I would put Ansible and CF Engine and what's not in that category, right? They're very much used and they will continue to be used, but they're not breaking anymore the boundaries of what we can or should do, right? That's reserved for tools that are slightly newer and more importantly with architecture that is based on different principles, because it is very, very hard to change architecture of something, right?
Gotcha. Kelsey, what do you think?
I mean, I think all things, we don't talk about things that work in tech. When things work, like TCP, there's no hype cycle. Is TCP dead? No. When things work in tech, they lose their hype and you just use them. And so, you know, when it comes to config management, there's so many ways of expressing yourself to a machine. And once we get something stable, you know, there's just not a lot of talk about. So yes, it's dead from the sense of, you know, do we need to have a big conference and hype around it? No, but it just works. Now the thing is, we're trying to figure out new ways of expressing ourselves to the machine. Right now, there's this idea that declarative, you know, minus all the code. You know, I think a lot of people went down the wrong path. Too much infrastructure as code becomes the same problem with having too much code in general. You got to test it, unit testing, it gets brittle. You have to refactor it. And a lot of software is abandoned, meaning people just stop factoring, people stop upgrading to the latest version. It just goes into maintenance mode because it just provides a lot of value. And so now we're all thinking like, hey, maybe this declarative way, the Kubernetes API style way, might be a better way of expressing ourselves when it comes to infrastructure. And it's not perfect yet. That's why there's so much talk about it, like, because there's so much work to do that lots of people are interested in who's doing the work, closing those gaps, complaining about the gaps, solving the gaps. And once they fix it, 5 years from now, someone will say, all of this stuff is dead too. And they'll move on to the next thing.
I think that's well said. And I think as you kind of talked about the infrastructure as code landscape, I would love to hear, I've heard you talking about the concept of infrastructure as data, as a pivot in and around that infrastructure as code. So maybe that is a good place to dive next based off of your answer. Could you tell us more about infrastructure as data?
At the end of the day, humans have to express to the machines what they want them to do. That is the core, fundamental, unshakable principle. And so today, the cloud and the target APIs are just flexible. Why? Because we're trying to service 10,000 personas. We're trying to service companies small and large. And so that means you end up with so many configuration parameters because we don't have just a VM. There's no such thing as just a VM. Depending on the provider, depending on your situation, depending on your requirements, you're going to have a different permutation of that. There's probably trillions of these configurations. And so some people believe in order to express every possible permutation, you can only do it with a programming language. If else, then do that for this each else. And you might be able to. And the answer is you probably can. These things are Turing complete. You can express anything. The problem is code brings a lot of complexity. So if you were to express yourself in Python, then you need to understand and read Python. And every tool in that ecosystem, if they want to do validation, they need to be able to parse your Python code and validate it. Multiply that by n number of programming languages because there's not just one programming language. So everyone's going to have their pick. Some people want TypeScript. Some people want to do it in Java. It doesn't matter. So that's the trade-off for expressing yourself via a full-fledged programming language. You bring in a lot of complexity. The other side of that equation is, where do we put this complexity? There will always be code involved because that's how machines work. And so in the Kubernetes model, you get infrastructure as data. So Kubernetes forces you to push all of this if-else logic into a control loop somewhere else. And you must expose the parameters you want people to interact with as data, aka YAML files, JSON files. It could be XML. That debate is unnecessary. It's just how humans represent data. And people tend to prefer YAML because humans tend to have an easier time writing YAML. So all the complaints aside about what data format to use, at some point, you have to serialize your intentions to the computer. And the industry, for some reason, has chosen YAML to do that. But the beautiful thing about doing infrastructure as data, as opposed to code, is that now you have a serializable data object. Now let's think about all the other tools involved. They can just parse data. And you can write those tools in any programming language you want, and they can manipulate that data, transform that data, merge it, slice it, add elements, remove elements, validate it without having to parse code. And some people think that form of serialization of our intent of configuration is easier to manage. And the last component here is when you can get to a data model that the world agrees on to represent the things and actions you want them to perform, you can use any front end you want to generate that data. You can use Python, Ruby, anything, and all of those tools can just output data, the intermediate representation of our intentions, and give it to the rest of the pipeline behind it to do all the data manipulations. And I think going forward, having an assembly layer of our intent, whether we write it by hand or we use some front-end tool to generate it, I think that's the holy grail of this idea of automating and configuring infrastructure.
Viktor, anything you want to add there?
No, this is pretty much aligned with how I see it. I often have conversations with people, hey, I don't like YAML, I would prefer to write it in Go, or I prefer in this, or I prefer in that. And my answer is in a similar line, like what Kelsey said. The question is not really how you generate data. The question is that you need to generate it and pass it to some API, right? In this case, Kubernetes API. Now, how you get to YAML or whatever else we're using is not that important for two reasons. Because first, it's easy for something on the other end to understand data, unlike all programming languages. And the second benefit that I really like is that it is also easier for humans to understand your intention when it is described as data. If you tell me, hey, go to this repository and take a look at this YAML, and you will find out what I wanted to do, that's so much easier than saying, hey, go to this Java code and go through all the permutations and if else statements and what's not to deduce that all I wanted is a VM, right?
And before we move on, we had a question that came in. It said, in this context, is there a meaningful difference between YAML infrastructure as data versus HCL Terraform infrastructure as data? Is this where we want to talk about the Kubernetes API? Where do we want to go with this one?
Yeah, I mean, the Kubernetes API, I think the thing that's more important than the Kubernetes API is the concept that it enforces, right? This concept of promise theory. There's a couple of ways of doing it. One is the cloud provider owns the resource. So they present an API. I am Amazon, and I have a service called S3. And I have a REST API for you to configure S3. And if you give me certain REST calls, I will configure it in my backend. And typically, I used to work at a cloud provider. We will take your request, and we have a background operation that tends to try to get S3 to be in that state at some point between now and the future. And if that doesn't work, we will just fail because we own the resource. So we're the only ones that are authoritative for making sure S3 is actually working. Now, on the front end, some people, in the case of HCL and Terraform, the default model that most people are used to is you install Terraform on your laptop. There are other ways to install Terraform in other places, but the actuation engine of Terraform gets installed on your laptop. And the way you talk to Terraform is through either JSON or HCL. And some people like HCL because you can do for loops and you can do all of these things to express yourself. So if you want 5 VMs via JSON, then you have to have 5 blocks of JSON objects to represent 5 VMs. Now, if you're using HCL, then you can do for blah, 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 and then have it create 5 VMs in a for loop. Some people prefer that and consider HCL a very powerful way to talk to the actuation engine, which is Terraform. Behind the scenes, Terraform is doing some, thing on its laptop against those cloud provider APIs. So that's one way of working. In the case of Terraform, you kind of get both. You have infrastructure as data, you generate that JSON object, or you have infrastructure as code where you use HCL. In the case where there's pure infrastructure as data, that's where Kubernetes kind of enforces this. The only thing you can submit to the Kubernetes actuation engine, the controllers, is this concept of here's my data object and it's typed. Typically in Kubernetes, we have a type system. So a VM is expressed as a Kubernetes object. It has a spec, it has a status. You give it to the API server and it stores it first. This is probably the biggest departure from most infrastructure as code, the way we treat state. So in Kubernetes, we say, hey, we want to implement all of promise theory, meaning you don't get to call the APIs directly. And instead, you give us your intent as data. We store it in a data store, and the control loop, any of them that want to operate on that data object, can then communicate directly with the cloud provider's API. And so that's the big difference, is more, maybe probably more semantic nuance. But I think the concept of having the state be represented as a typed object and understanding that someone else controls what's going to happen to that data, or by parsing that data and updating the status field, I think that's the big difference between the two approaches.
Anything you want to add, Viktor?
Again, it's hard not to agree. I agree with Kelsey. I mean, the biggest difference really is, and what I believe is complicated for people to grasp, is that we are giving away part of our control, right? Some of the things that we are doing as humans, we are now delegating to some processes. In this case, for example, Kubernetes, right? I'm going to give you that data and you figure out what to do with it, right? Instead of everything happening right in front of our eyes, right? We are just stating the intention and letting the controllers figure out how to convert that intention into something tangible.
So I think from here, or I think we're inching towards this already, but just to make the question explicit, let's talk about the overlaps between infrastructure as code systems and control plane. Because I know, Kelsey, in the past, you've kind of tweeted as you were exploring tools that there's a good degree of overlap between Terraform and Crossplane. So can you help us kind of understand, what are the use cases for IAC? What are the use cases for control plane? When are they complementary? And let's kind of dive into that part of this.
Yeah, the thing, just being transparent, the thing that makes Crossplane even interesting right now, do we need another configuration management tool? We have Pulumi, we have Terraform, we have Puppet Chef and Ansible, and then you combine that with all the homegrown tools that either cloud providers have or you have at your organization. I don't know if anyone was like, we need another one. So what makes Crossplane interesting is that we can finally move to control plane land. There's a distinction between like automation and abstraction. The cloud abstracts things. Most people get it confused. Automation is what you do with VMware on-prem, right? You say, oh, give me a VM, and you tickle all the APIs and you make it work. In the cloud, there's a different form of abstraction that says, here's one big control plane. It has billing, it has observability, it has security, it has all these other things that you can do with this control plane. And everything underneath the control plane is attached via an API. So if you want a VM, you can only express that as an API object, which is then calculated towards your bill. Other things can be attached to it, like networking components, VPCs. The whole thing is one big abstraction over compute. And in order to do that in a self-service model, the cloud provider gives you a control plane. So when you say AWS console, GCP console, Azure portal, what you're talking about is a control plane representation of a catalog of abstractions. That's a beautiful thing. Once you have a control plane, you can use any front end you want. That means you can have a UI where people do click ops, click, 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 click. That works. So the UI becomes the interface or the front end to getting those resources. You can use Terraform by pointing it at the same APIs, and then it can do things. But Crossplane is different. Crossplane, you can totally use it as a drop-in replacement for Terraform. So maybe you like infrastructure as data is better than just writing HCL, the way Terraform does it. So you can use it as drop-in replacement, and then you're kind of one-to-one land. You'll just see a bunch of typed Kubernetes objects that mirror their counterparts in other configuration management systems. That is, you can totally do that. But to me, what's more powerful is to shrink the surface of your cloud provider's control plane, or add a control plane where you don't currently have one. It's like on-prem, most people don't have a unified representation of all the things that you can do with their storage arrays, et cetera, et cetera. So imagine a world where you can take all of that automation expertise and decide that you also want to have an abstraction for how networking gets done, how VMs get spun up, just like a cloud provider. And so if you were to think about using control plane or contrast plane in that way, what you end up with is potentially in the future, an API representation of all interactions between the different components. Maybe you attach billing, security, validation, policy engines to the control plane. And then your consumers can continue to use Terraform. If they want to represent and articulate to your control plane via HCL, it should just work. And if you want to use Puppet, Chef, and Ansible, all of those should work. Why? Because you are intentionally designing a control plane surface that acts as a facade to the cloud provider itself. And so you become the front door. So if you're doing multi-cloud, what makes that difficult for some people outside of networking and the weirdness between the different types is that if you were to put a unified control plane above that and you say, hey, we have this one unified control plane that normalizes the API surfaces below it, then you get into something special. So I think you got to think about, am I building a control plane or am I simply automating someone else's control plane?
Go ahead, Viktor.
Yeah, that's the difference. Early on, Kelsey, you said that cloud providers, hyperscalers, are designed to serve tens of thousands of users, right? And that's why they have all the different hundreds or thousands of settings, right? Because they need to account for all the permutations. What you want is to build some kind of service that fits your needs, to expose that service to your end users, just as AWS is exposing to you as a sysadmin or whatever your role is. You want to create your own control plane and say, hey, this is what, in my context, it means to have a database or a cluster or networking or whatever it is, right? To define what something is within your context instead of going directly from the user to the hyperscaler, which has all the possible permutations, right? That are not frankly needed for every person, right? So it's defining yourself what it means to have the same benefits as control plane, but under your terms in a way.
Gotcha. And looking at the time, I think we'll probably have time for one last discussion question. So let's go to this future land question and where we go from here. I think in some cases, we're already starting to see tools like Pulumi experimenting with creating infrastructure using natural language. But I'd just love to get your thoughts on just where declarative tooling goes from here and what we should be thinking about in terms of overall trajectory and direction of travel.
I mean, humans across centuries, we have how many spoken languages? And then on top of the spoken languages, what do they say? 70 to 80% of communication is nonverbal. And so there are so many ways of expressing yourselves. And then you think about the mental models we all walk around with, just humans in general. We have a mental model of the world. If you frequent the airport all the time, you're probably a pro at it. And you know the difference between global entry and pre-check. Some people don't. And they have to ask a bunch of questions till they get to that point. Then we can use signage to tell people which way to go. Look at your boarding pass, you see the logo, you go there. So we have a lot of ways to configure people in the world, right? Spoken languages are probably the most powerful programming languages ever. But then when you get into like large language models, these different approaches, what I hear when people say we want to use natural language to manage infrastructure, listen to what you're saying. I want a VM. Okay, so what's the context there? So depending on the thing you're talking to, it better have a lot of context. If I'm talking to the AWS cloud provider, create a VM. What region are we talking about? The default region, the last region you deployed to, the only region you're allowed to deploy to? There's a lot of nuance there. So in the humans world, when we say, I want something, can you afford it? There's going to be a whole nother conversation. Like, yeah, everybody wants their own private jet, but can you afford it? No, you can't. You cannot have one. So the answer is no. It's really hard to do that to these simple machines that we're dealing with, because honestly, LLMs may not be what you want in this realm. In our realm, the domain is actually scoped much tighter. There's only so many ways you can create an S3 bucket. I think what we're talking about in this way of using programming languages, your YAML file, some people don't know what's valid configuration. So the discovery process is very hard. So if I say I would like a VM, you can guess that I want an Amazon VM and generate the YAML file for me as a rough draft. Given that this infrastructure stuff and security should be intentional, you should take that rough draft, that prediction, that guess, and make it more concrete. So I think in the early phase of LLMs and natural language for configuration management is rough draft mode. You as the human are responsible. So you need to serialize your intent and decisions. And if you're unsure what these fields mean, you need to go talk to someone, or someone in the code review process should say, hey, cool, you're using whatever tool to generate this, but this is wrong. This is not our intent. This is a guess. And we don't need to be guessing about security right now. We actually have policies we want to adhere to. So I think what we're going to see in the future is that companies will have better sane defaults. You will be able to use a language prompt to get you close to that same default. And it's going to be a rough draft. And you're going to have to be responsible, because you can't delegate your responsibility to some large language model for guessing. So I think that's what's going to happen. And it all screams that people want a better API for expressing themselves to the computer.
Wonderful. Viktor, bring us home.
No, that's you need to mute yourself. Sorry. We are far from it, right? Simply, I believe that if we would start solving that problem right now, we would be solving a wrong problem, because generally people do not have any issue writing YAML or HCL or any of those things, and then we need the simplification of that. We have a problem of, how do I know what I want to do? How do I decide which 57 different components I need to combine in what way, and what are all the details of doing all that? And once I figure that out, writing YAML, HCL, or whatever I'm using is not a problem, right? That's the least of the problems, as I see it right now. So yes, we are going in that direction. We'll get there, but we're not nowhere close, right? As a way to help me and say, hey, what Kelsey called rough draft or something like that. Hey, maybe this is a good starting point for you. That, yes, I mean, I do that myself, but we are far from anything else, mostly because the problems are elsewhere.
Wonderful. Well, Kelsey and Viktor, thank you so much. And we'll turn the floor over.